Hello, everybody. How are you? Not tired? It's evening. Hope you're not so much tired. This is a light session. So we're going to talk today about code coverage. And before we do this, let me introduce my colleague, Marharyta Nedzelska. She's staff software engineer at Sonar. She's also a Kotlin Google developer expert, so please welcome.
And I'm happy to introduce my colleague Evgeny, who is principal software engineer at Sonar, so we work at the same company. And he is also JaCoCo project co-lead, and he's going to be responsible for code coverage today.
Yes, so we both work at Sonar. Let's do a quick check. Do you use our products, Sonar Cube, Sonar Lint, Sonar Cloud? We hope you do.
Don't be shy. That's not a sin.
Don't be shy. You can like them, you can hate them. We don't really care today, because today this talk is not at all about these products. And whatever we are going to tell you today is just our own opinion.
And there is one more important thing you should know about me. I am from Ukraine. I was born and raised in Kyiv. And for almost all my life, I lived in Kyiv. And today, you probably heard that my country has huge troubles with our closest neighbors. And we need all the support that the world can give us. So if you feel like you want to support Ukrainians, here the QR code link to Trusted Charity Fund. Feel free to take pictures and scan it. And we really appreciate your help here. So the most important and the most serious part of the talk is done. Now let's have some fun.
Apparently today I'm going to be responsible for the fun part of this talk.
Then we all are doomed here.
Sorry.
So have you ever seen MythBusters?
Yeah.
Yeah, I remember when I was a kid, I really adored this show. When I was a little bit grown up and I saw the show again, it was not that funny anymore, but still interesting. So today, we're going to try to do the same. As you probably remember from the TV show, they tried to reproduce some circumstances of some common myth, common beliefs, and either confirm or dispel them. That's what we're going to do with the myth about code coverage. And what's our first myth? I'll let you pick up on.
Thank you. Let's maybe start with a pretty simple question to the audience. What's your code coverage target, like percentage of the code which should be tested in your applications that you develop? Maybe 0? Who thinks that we should just ship into the production, no tests, nothing?
Who care about tests? Yeah.
Don't care about tests. I think it's a great approach, actually. So maybe 30? No? Higher? 60? Wow. 80? Oh, yeah, OK.
I'm curious from where they're taking this number.
The average is 80, that's 9. Maybe somebody is shooting for 100?
Yes.
It's a great value. What about 110?
Yeah, like 2 hands.
So I propose that our myth will be code coverage should be 100%. What do you think?
Yes, I agree. And I think it's even written in some books that code coverage should be 100%. And to me, and I think it's common belief that in the same words, you can say that if you can write one line of code, you can always test it. You can write one test that tests this line of code. So today, we are going to try to dispel or confirm this myth by using pair programming and ping pong. I'll be writing the code, and Evgeny will be writing tests for this code. Because I am a responsible developer, I prepared my part beforehand, and we have already my examples. Apparently, Evgeny is not, so he's going to write all the tests live today.
That's how principals do, right? They don't prepare. OK, so what you got here for me? A simple sum. No talk today happens without II, so thank you. Copilot, I think I got a test.
Yeah, so 1 plus 2 is 3. I think I agree. Looks like you covered everything, so I expect 100%.
OK.
Yes?
Should we try?
Yeah, let's try to run them.
OK. So Let me...
Clean install, yes?
No, clean verify. Nobody today should use install. Even clean is not necessarily, but let's try. Build successful, test pass. Should I look at the coverage?
Yeah, let's look at the code coverage report. And as Evgeny is co-lead of JaCoCo, today we're going to use this tool, Java code coverage, and it shows us an interesting result. For some reason, it says like nothing is covered. Yes?
That's unbelievable.
Yeah, I think that's my mistake. Sorry, because I prepared the example. Let's check. Yes. You can see that the import of your test, of your annotation, is coming from org JUnit test, so it's JUnit 4.
What's wrong with JUnit 4?
Nothing is wrong with JUnit 4 if you're 10 years ago. But let's go and check our POM XML.
Okay. What do you expect to find here?
You can see that we have JUnit 4, but we also have JUnit 5. And which one is actually executed? Apparently, we tried to execute tests from JUnit 4 with JUnit 5 engine, which is possible, but to do so, we need to add the vintage engine. Have you ever faced the problem like this? Have you ever forgotten to add vintage engine in your life? Like in my company, I had a lot of situations like this with my colleagues. They always forget to add vintage engine when they migrate from JUnit 4 to JUnit 5, and tests are not run. So what's going on? The coverage shows you which part of the code was executed. And because the test didn't run, nothing was executed. And
we could have debugged this, right? If you would just look at above, number of tests would be 0, right?
Yeah.
Okay.
So what we are trying to say here, we just faced our first myth that we dispelled, that zero code coverage is always bad. Why? Zero code coverage doesn't say, sometimes it doesn't say that you didn't cover something. Sometimes it says that your tests weren't executed. So in some situations, zero code coverage can help you debug and find the problems. For example, if you just saw the success and go ahead, you might not notice that your tests weren't executed. In our case, with zero code coverage, we understood that our tests weren't executed and fixed our problem. So in some situations, zero code coverage or lower code coverage is a debugging tool. So code coverage could be used as a debugging tool.
You know what? I just got an idea. Who is using Eclipse here? Other Eclipse users? Some? As you could see, I don't use Eclipse. I use IntelliJ, but in my life it happened that I inherited some Eclipse project. Actually, I inherited maintenance of JaCoCo code coverage plugin for Eclipse called ECL-EMMA. And I know nothing about Eclipse, but I have to maintain this thing. I know nothing about Eclipse and about this project code base, but I get some user report. And some user says, well, you know what? In Eclipse, when I hover over coverage S, I get some strange exceptions in my log and my console. And that's the report. How could I debug this? There is no breakpoint. I don't even know where to put the breakpoint. So what I could do, I could actually run this plugin in Eclipse with code coverage.
So you're going to debug Eclipse in Eclipse?
Yes. You can do the same with IntelliJ. You can debug IntelliJ from IntelliJ.
OK.
So Eclipse is starting. Here is my new Eclipse instance. It runs with code coverage enabled. Here is some example project. I could hover over this line. Yeah, you see that some exception, something happens, but none of those exceptions points on actually our plugin. So where to put the breakpoint, we still don't know. What we can do, in original instance, we could ask to dump code coverage results and to reset what we collected so far. Let's just do it one more time to see that it's 0. Yes, it's 0. And in this instance, we can do the action, like hover over, and ask for code coverage again. And what we are going to see in the code coverage result is exactly what was executed when I was performing the UI action. So this code was executed. So now I know that probably I put a breakpoint here.
Nice. So technically, you can use code coverage not just to measure the coverage, but also to find the way what was executed and use it as a debugging tool. So just another myth that code coverage is used solely to measure coverage is busted.
Yay.
Yeah, let's continue with our examples.
Okay.
I think I prepared something for you. Okay. So we've recently been to a few conferences, and this is actually our third conference in a row. It was KotlinConf, JPrime, now it's JNation, and next week we are going to be in Barcelona for the FBCN. So we are at a stupid simple function to identify what is the best conference in the city, and city is enum.
And you don't want my life to be simple, right? There is 4 values. So.
Yes, I want you to write 4 tests. And I want you to make some copy-paste mistake, of course. Have any of you been to KotlinConf here? Who actually uses Kotlin? Just, you should use it, it's perfect language. I was not, but Evgeny, I was not allowed to speak about Kotlin at this talk because it's a Java talk, Java conference, but I'm Kotlin GDE, I have to, I cannot live without it. So are you ready with your tests?
I hope, yeah, I'm done. There is 4 enum values, so 4 assertions. Here is my test.
So I think you covered everything, yes?
I hope so.
At least I don't know what more to cover here. I expect 100%. Let's run the tests.
Okay. You're not tricking me with JUnit 4 anymore, right?
Yes, I hope we fixed it.
I think this time I use JUnit Jupyter, just to be sure. Okay.
So use JUnit 5. If you take one thing out of our talk, that you should use JUnit 5, not JUnit 4.
Yay, some coverage, but...
It doesn't say it's 100%. What's wrong with your tooling? Okay.
Come on, it's not my tooling. Come on, enum has 4 values. There is no way I could cover this default. Like it's not possible. Come on,
we put a statement in the beginning that if you can write 1 line of code, you can test it.
Okay.
And
what you would suggest?
I would suggest let's use mocks here.
Mocks?
Let's try to mock.
Okay.
I know you're a principal developer. Probably you'll never write mocks in your life.
But let me try. So I'm going to have my mock. What do I want? I want when I am asking for the best conference, then...
We need to test some default case.
The return default case is now, so I will return now when I'm asking for the best conference. And I'm going to do the assertion that I'm getting now when I ask for the best conference. Oh, there is refactoring. I can simplify the assertion. Here we go.
Yeah, let's run.
Okay.
Okay. So who thinks everything is covered now?
Sorry.
Oops.
What?
What's going on?
A demo effect.
Demo effect, yes.
Something is not quite
Something
right.
is not working. So apparently,
let me try to do something.
it's principal developer writing mocks for the first time, so demo effect, let's forgive him.
What's going on?
Are you in the right folder?
Yes. But okay, let me maybe try like this.
Okay.
I'm doing the same action, hoping that compiler will give up.
When I was the mock
You're trying
inside
to
before
stop
the,
final
I think
method.
you're,
Ta, 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 ta.
yes.
Sorry, Makita, do return now.
Best conference,
yes.
yeah.
Yes, so
Yeah.
you see I never
Yes.
write
Okay.
mocks, so I don't know how to do that. Should be better now.
Yep. You spot it. Yeah, like.
Thanks to the audience. Yay,
Yeah.
build successful.
How many developers do we need to write mocks?
Okay, you know
And
what?
I think it still doesn't work.
It didn't help it. You know what? I heard this. I've read this even in Makito issue tracker. I think mocking doesn't work with code coverage. It's simply not possible.
Do you believe it? Do you believe that code coverage doesn't work with mocks?
Come on,
I think
I
the
have an
audience is
example.
tired. Yeah. Let me a little bit explain you what mock is, what you actually did. So when you mock something, it is not going to be executed. So what you did, you mocked the best conference function, and then you ask to execute it again on the mock. So you actually asked to return null instead of executing this function. You're not supposed to mock the function that you test. You need to mock the dependencies of this function. So this time, let's try to use mocking properly and mock enums.
Mock enum?
Yeah.
Are you crazy? Enum is final.
Do you think we can mock
you
enums?
really mock enum? Okay, and when we are mocking enum, we really need to mock ordinal, I guess. That's about what is gonna be used for the switch.
Have you ever mocked enums in your life, actually? I also don't know if it's gonna work, but at least let's try.
Okay, let's see. Wow, that's crazy.
So
That's
it's
some
still
black
possible
magic.
we wrote one line of code, and then we can write test for it.
But that's black magic. Come on, enum is final. You're not supposed to be able to mock the finals.
But we have 100% now.
Yeah, but hold on. Let me try something. You know, I don't trust the black magic.
Okay.
And you know, black magic with JVM tends to be not supported in future JVM versions. So which Java version we use? 21. Let me try latest of
Early
the
access.
latest, like early access build of JVM.
Let's try 25.
25 doesn't exist. 23 early access, a couple of weeks ago, it was published. Can I try that one? Ooh, doesn't work.
So you see, mocking doesn't always
something
work.
crashed. Yeah, something crashed. So I really hate a magic behavior. So you know what? Even some people say this to us, that JaCoCo should ignore this line. This would be great, but, well, if JaCoCo can ignore this line, then probably compiler can also ignore this line. But you see, compiler tells us, well, the default is still needed to initialize X. To solve this problem, Java developers, you know what? They introduced a switch expression. We have Java 21 in our project, even now 23. We can use modern features, switch expression. Can I refactor this?
Yeah, let's do.
Okay, so.
Does IntelliJ have such refactoring?
Not directly, but I think we can do like 5 hops and we got our switch expression. And now I think I don't need this black magic. And now I think I can just execute.
And do you think it's gonna run in Java 23?
Yes, I'm on Java 23, build successful. Let's look at the coverage.
Okay.
Oops. 100.
So you see, another takeaway, don't use switch statements if you can use switch expressions.
Okay, I think there is a better takeaway.
Yes, that we learned that code coverage actually works with mocks if you know how to write mocks.
Okay, should we move forward?
Yeah, I think I prepared another example for you. So this time a little bit less cases.
Thank you very much. Just 2 cases, right?
So here's a stupid simple function to calculate the
You learn
perimeter.
it, yes. We can use modern features, sealed interfaces, records. Oh, you know switch expression, actually, but you didn't use it in the previous example. Fine. OK, what do you want?
You're talking like my manager.
Yeah. What do we need to test here? We need to. You want to check whether I know how to compute perimeter.
Yeah, or maybe whether Copilot knows how to.
So let's do the perimeter of rectangle, and let's do the perimeter of.
Do you agree that's the right way to calculate it?
The square. That's fine.
Oh, looks like it. Okay. Let's test it.
Ouch.
Oops, something is not covered. You know what?
Hold on. Oh, can I look?
Yes.
Oh, there is some branches. That's weird. What would you suggest?
I don't know. Remember what we did last on the previous example?
We changed
we
Java
changed
version.
Java version.
Can I try to go back?
Yes, and looks like JaCoCo is not yet ready for that version.
Well, shit happens. Oh.
So you can see we changed. Oops. The only thing that we changed was Java version, and it broke the coverage. So if you thought that code coverage does not depend on compiler, you were wrong, because it still depends. And maybe, Evgeny, you can explain why?
Well, all the tools that today exist on the market, most of the tools that exist on the market, they work with the bytecode, the result of the compilation, not with the source code. And obviously, the result compilation depends on the compiler. So that's easy. If you want to know more, just watch one of my other talks.
Yeah. I hope you know how to write mocks there.
I don't write mocks, I already told you. Should we move forward?
Yeah, let's go.
Do you have examples?
But you'll fix this in JaCoCo, yes? Or
for the next Java version release, I will try to fix this thing.
You know, this talk is recorded. So.
Maybe I should, instead of giving talk, maybe I should go and do some fixes. This time, what do you want me? You want me, again, best conference in the world.
Yes, today we simplified a little bit the switch, only with 2 recent conferences.
G prime, JNation.
And
there is switch expression. Yeah. Again, enum, 2 cases, but switch expression should be fine like this.
Yeah.
I think so.
I think so too.
Why we are focusing on the tools that I maintain? Maybe we should try some other tools.
Do you want to run it in IntelliJ coverage? Yeah, you know that in IntelliJ you also can run with code coverage.
But this is a different tool, right?
Yeah, but this is a different tool. This is not JaCoCo. This is the one prepared by JetBrains.
Yeah, look, this time, first shot, 100%. I am good.
Yeah. Perfect. And you also know, because we work at Sonar, Sonar can measure code coverage as well.
No, Sonar doesn't. Don't lie to people. Sonar doesn't measure code coverage.
Okay, Sonar
imports code coverage reports generated by JaCoCo.
Come on.
Yeah.
Why are you so smart?
So, should I try Sonar?
Yeah, let's try and look at Sonar.
You expect something different to be shown in Sonar?
Let's run. Don't talk too much. You know, we are not supposed to run NVN Sonar.
It's deprecated, but it still works. That's fine. I will migrate later, okay?
Because we plan to drop this in the upcoming releases.
So.
Yes, it's slow.
You are a developer of this tool, right? You should speed it up. Not for a live demo, come on. So, what do we have here? Let's look.
Code coverage.
Overall. I told you, 100.
Okay.
Yay.
So as you told us, Sonar imports reports from JaCoCo. So let's look at what JaCoCo says to us. Because if Sonar imports wrappers from JaCoCo, the two wrappers should be the same.
What?
So you see.
What?
And I think this is another myth that we just busted. Can you
Open
back
the
to the
myth?
presentation? Yes. That code coverage is the same in all tools. First of all, code coverage might be different between different engines, like IntelliJ Engine or JaCoCo. And another thing that it's also different between Sonar and JaCoCo while they're using the same wrapper. So this is because the different tools calculate coverage, calculate numbers differently. So you need to read the documentation to understand what is actually calculated.
So JaCoCo tells me that I am not covering something on this line. Oh, probably it's lambda, right?
Yes, and the fun part that JaCoCo is actually right here, because we never tested the exceptional path.
But it's kind of, again, not possible. But OK, this time I know that I can actually mock the dependency. In this case, the dependency is load conference, and I'm going to return optional empty. Should be fine.
Yep.
So, and we expect, oh, thank you, Copilot.
So generative
Should
AI
be
works,
good.
yeah?
Yeah, should be good now.
Let's
try.
test.
I'm not going to execute Sonar. We know that it gives us shitty result.
Come on. You work at that company.
I will open a ticket
So
to fix
now
it.
JaCoCo is happy. So everything is covered because we covered the exceptional path. But you know what? Since we are going into that direction, trying different tools, let's try another tool.
Which one?
Let's try p-test. Like, have you heard about mutation testing ever? So let's try to see what's going on mutation testing here.
OK. Yeah, so if you haven't heard, there is a tool in JVM world called p-test. It's a mutation testing tool. What is mutation testing?
Actually, for those who haven't heard, mutation testing is another way of checking the coverage of your code by tests. So how it works? They introduce the change into your source code. Not into your test, but the source code. And then if after this change, all your tests passed, that means that this mutation survived, and your tests are not covering some part of your code. But if the tests fail, it means that this change affected your tests, and it means that your tests are good enough. So in our case, there was one change in our source code that still passed. Let's check what it was. So you replace the return value of the lambda with null, and it still was fine. So let's do it.
So p-test tells us that we can actually replace what? This with a null.
And yes.
That should be a null pointer exception. Come on, you cannot do this.
Yes, and
Oh, our test passed.
but our test passed.
What?
You know what?
How is that possible?
Because we are expecting the runtime exception. And you know, null pointer exception is also a runtime exception. So it's not enough just to check the runtime exception class. We need to check exactly by get class.
Oh, yeah, now better. Now it fails.
So now it fails.
So I can return the runtime exception, and we hope that p-test are going to be happy, right?
Yeah.
Where is my console? Let me try to get back my console.
Yeah.
p-test.
So p-test. Okay.
Yay,
Now
p-test
everything
now
is
happy.
covered. But you know what?
What?
Let's try to change the error message.
Okay. Why? What you're trying to say is that even...
I'm trying to say that because we don't check here error messages, it still can fail. But mutation coverage didn't tell us that we are not testing the error message here.
Okay, so you are saying that this is the best test, right?
Yeah, so now we covered everything. So what we are trying to say, I think let's get back to our myth here, that first of all, line coverage is not enough. That's what we showed you when we said that Lambda was not covered in JaCoCo, but it was covered in IntelliJ and in Sonar. Then, when we saw 100% of code coverage, that was still not enough to say that our tests were good, because mutation coverage showed that something was not covered.
Okay, but even mutation.
And the fun part that even 100% of mutation coverage doesn't guarantee test quality and quality in general.
You know what? Our customer actually wanted to load this from database, and
Yes.
we are not testing this.
Because the point is that no tool can guarantee the quality of your software. Like, you can use them, they can help you to find some problems, but no tool can say you that your software works 100% correctly. Because like, no software can know what are the requirements. That's why we still need people here.
Okay, so
Or AI.
speaking of quality, let's go back to the Sonar Cloud report. Here, our just written shiny project with 100% code coverage. And can we use this metric to compare projects? Can managers use this metric to say, well, this team developing this project performs much better than, let me pick another project, like
for example,
much better
JaCoCo.
than this project. Yes, it's actually JaCoCo itself. Look, code
So
coverage is not 100.
So you look, the JaCoCo tool that we are using to measure coverage doesn't have 100% of coverage itself.
Which project would you trust if you need to pick between these two? 100%?
Of course, this one,
coverage.
it's all green. Like.
Okay. Let's look at what is not covered in JaCoCo. I can show you one of examples, like what do we have here? Oh, that's our good old friend, Switch. Switch by Enum. And you know what? I don't want to cover this thing, like, sorry, but I'm not going to introduce a dependency on a mocking framework which can break with Java version upgrade. I can just ignore this, it's fine. And, well, sorry, I cannot use switch expressions here. We still need to be compatible with Java 5.
Is that because of your manager?
No. It's because of our users.
So, yeah, what we are trying to say here, that code coverage is a developer metric. You can or you cannot show it to managers, but you cannot use it to compare the project, to compare the velocity of the team or how good is the team, because it's just a number. It says nothing about the quality of the project, and it should not be used to compare the different projects and to tell what to do. And you might probably notice that we did stupid things just to reach 100%. We introduced mocks where we had to be binded to some Java version. We introduced some stupid tests that we didn't need, just for the sake of reaching 100%. So code coverage is not for managers.
Okay, are we done?
No, I think there is one more thing that we need to discuss here, because so far we've been focused on the correctness and on the code coverage itself, but we are developers. We love physics, and in quantum physics there is a concept, and there is.
We are developers. We love physics. Yeah.
Don't you?
We are engineers, and engineers love physics.
Okay.
Yeah, I love physics.
So, and you know, in quantum physics there is an observer effect. It tells us that the fact that we are observing something might change the observable. And I'm curious, the fact that we are measuring code coverage, does it affect something, for example, performance?
This time I prepared something for you. This time I came prepared.
So you have a benchmark?
I have a benchmark. Let's look at the benchmark. So, what do we have here? I have a simple, stupid Fibonacci numbers calculator, like this. We pass a number, and we get a Fibonacci number at this index. I'm not going to write assertions for these tests. I hope you will trust me that this is a Fibonacci number calculator. That's not really important whether this code is correct or not. We want to look at the performance. I'm going to use GMH, Java Micro Benchmark Harness, to measure multiple things. There is a little bit of magic you're not interested in, but, well, we are going to take the original class. Here is original. We are going to instrument it using JaCoCo. And we are going to instrument it using JetBrains coverage engine, the same that we can see on the default settings in IntelliJ IDEA. And we are going to run this using GMH and measure what it takes. By the way, I'd better already run and then explain what is happening, because it's going to take a while. So we're going to measure nothing. Like, it's going to be our baseline to see that our measurements, they make any sense. Then we're going to measure how long it takes to compute Fibonacci number without any coverage measurement. And then we're going to measure what it takes with JaCoCo and what it takes with JetBrains coverage engine. So 50% complete. I should have executed it at the beginning.
You should have executed it beforehand.
Yeah, sorry.
But we still have 13 minutes. Will it finish in 13 minutes?
75%.
Yeah, okay.
We're good on track.
So I think I know people who develop GMH.
Okay, so here is our result. What we can see here, well, no operation takes some time because we're probably measuring the GMH infrastructure. So measurement affects what we measure. It's not a no operation. Then we can see that computation of Fibonacci number is obviously slower than no operation. That's what we expect. Seems that our benchmark makes sense. Then we have JaCoCo. Well, it's a bit slower than the original. And then we see JetBrains coverage engine. Wow, that's like 4 times slower than the original. So yes, I think measuring code coverage does affect performance of the application. Look at the numbers.
JetBrains is what is executed when you do it in your IDEs.
Yeah, I think we should change the settings in the IDEs. I think there is some setting to switch to JaCoCo.
You see, if you try to execute the code coverage through IDE, you need to understand that there is some performance cost here.
Well, even from the command line, there is some performance cost.
Yeah.
And you know what? I even heard some stories where people were executing code coverage in their production system.
By
to
mistake?
understand, no, not by mistake. They wanted to understand which code is not touched by users, to delete it, unused code. And actually, well, this is just a micro benchmark. Your melange may vary from use case to the use case. Those guys, they're not dumb. They were not doing this by mistake. They did a proper measurement, and they found out that in their case, in their production system, the overhead was far less than 1%. And this was acceptable for them.
So, like, yeah, even if we look at our benchmark, it still depends on your code, how big is an impact, but there is definitely some impact.
Okay.
So,
should we move on?
Yeah, let's move on.
What?
I think we talked about the performance, but performance is one thing. But the program that we are actually executed, is it still correct when we introduce code coverage on the program? Do we actually change the program itself?
I came prepared again. I have another example for you guys. So, in the Java virtual machine specification, there is an interesting property, structured locking. Structured locking is a situation when, during a method invocation, every exit on a given monitor matches a preceding entry on that monitor. This property requires cooperation between Java virtual machine and the compiler. And this property is perfectly satisfied by the Java compiler. It's not going to be broken. Then developers of code coverage tools like JetBrains, JaCoCo, etc., they learned the patterns that compiler produce, and they adopted to those patterns. So by instrumenting the compiler-generated code, we do not break this property. And we developed those tools for the Java compiler. And then, bam, surprise, we got some non-Java languages running on the JVM. For example, Groovy. And then, bam, another surprise. We actually got man in the middle between the compiler and code coverage measurement, there might be another tool. Like Android developers know this tool very well. There is R8 shrinker that is going to shrink your bytecode to be able to run on the Android device. And those tools, or Groovy compiler, unfortunately, they generate a pretty weird bytecode, which after instrumentation by code coverage tools are going to be with a broken property, with this property broken. To show this, well, I need to generate some bytecode. It's not important, but what is important is that we are going to run this bytecode non-instrumented and instrumented by JaCoCo. And we are going to look on whether this property obeyed or not, so we are going to ask for the monitor mismatches. And we are going to ask JVM to do JIT compilation of this bytecode. Let's try. And here is what we're going to see. When we run original, there is no error message from JVM, from JIT compiler. And when we run instrumented, unfortunately, we are going to see the warning, monitor mismatch in the method. This warning means on the hotspot JVM that, well, these methods are never going to be JIT compiled. We broke the property that prevents JIT compilation of this method.
But it doesn't break the application, it just affects the performance.
Hotspot JVM is pretty good. Hotspot JVM says, OK, this property is broken, then we should execute this method in the interpreter mode, and then this property will not be broken. Unfortunately, Android runtime is much stricter than that. On Android, when you break this property, your entire application is not going to work.
Okay.
So, well, yes, there is a bugs in code coverage tools which can change the behavior of your application.
Okay, so I think we just got to another myth that measuring on coverage affects your application, so you should keep it in mind. So,
let's go back to the myth number one. What do you think?
Should code coverage be 100%? Are you tired? Yeah.
Well,
so
no.
I hope we proved today that code coverage should not and cannot be 100%. Code coverage should be at the level when everything that is supposed to be covered is covered. And I know that it's much harder than to have some number target, but this is the way to go. In ideal world, it should be 100%. But in the reality, we cannot have 100%, and maybe there is some way for improvement on the tooling side. Maybe we need some way to accept or won't fix code coverage misses in tools like JaCoCo, or probably in Sonar, or in the way how we show code coverage.
You're again trying to finger point on JaCoCo and tell me that I should go and implement some feature, right?
No, I'm just saying an idea.
Let me ask you a question. Every time we introduce a thing like this, accept or won't fix, what happens on the next day? Who tests the tester? Who monitors? Who guards the guard? The next day, managers are going to come and ask you, you know what? We want to track the metric of won't fix.
As I said, we are all doomed here. So, code coverage should be 100%, busted. So there is some short summary that we want you to take from this presentation. First of all, code coverage is a developer metric. Don't use it to think about the quality of the project and not show it to your managers. Tools are not ideal. You might see that tools depend on compiler, tools depend on different things, and there are some compiler artifacts, and tools are different. So we cannot trust them completely, but tools are still helpful. So even when something is not covered, and even if it's a false positive or if it's a mistake, it's still interesting to dig in to find out why, and maybe you'll find some bugs on your side anyway. So don't try to please the tools. Don't try to reach 100% just for the sake of 100%, but use them smartly and try to cover what is not covered for your application. So
we hope you enjoy it.
This is it.
Thank
you for attending.
And I think we have like 5 minutes. If you have some questions, we can take them. Otherwise, we will just make a photo.
Yeah. Yep.
If you are shy to ask questions now, you can catch us outside and we will talk about whatever you want.